To begin, let us first take a look at what all steps are involved in executing our project. As we do each step, we shall review the tasks that are involved in that step in detail. First, we shall import the necessary Python libraries. Then we shall load the input data. This step internally sets up Python's data structure called data frame for our processing. Thereafter, we pre-process the data, which includes cleaning and exploring the data. Under cleaning, we shall cover how to handle bad data and the data with incorrect format. Under exploring, we shall understand how to visualize the data. The topics in this are univariate analysis, that is analysis of one variable at a time, and bivariate analysis, where we shall study the correlation between two variables. Both of these can be either numerical or with graphs. Next, we build and execute our machine learning model. This is the well-known standard machine learning process. Under this step, we shall first set up the input and output variables, then divide the data into train and test sets. Thereafter, train the model, predict the output by running the test data, and lastly, validate the accuracy. Lastly, we shall explore the various alternative approaches to the solution with a view to improve the result. Under this, we shall repeat the above process with a new approach and compare the results. Also understand what can be done in future to get higher accuracy. Now we are moving to the first step, that is importing the libraries. Importing the libraries. As we know, Python derives most of its power and flexibility from the large number of supporting libraries. Each library contributes a particular functionality to Python's collection. Let us first run the instructions. I am going to type each instruction and run it one by one. You can also do the same as we go. Import pandas as PD. Import pandas as PD. Import numpy as MP. Import numpy as NP. Import matplotlib.pyplot as PLT. Matplotlib.pyplot as PLT. Import Seaborn as SNS. From sklearn.linear model, from sklearn.linear underscore model, import linear regression. Linear regression. From sklearn.model selection, import train test split. Train underscore test underscore split. Split. From sklearn, import matrix. Matrix. Percent matplotlib space inline. Percent matplotlib space inline. Now let's run this. Shift enter. So as they are running, we will see what each one of these are. Now quickly review the role of each of these libraries we are loading. Pandas is for handling data structure. NumPy for arrays and scientific calculations using numbers. Matplotlib and Seaborn help us with charts and data visualization. Scikit-learn is designed for supporting machine learning operations, including algorithms. As we can see, train test split does the routine job of splitting input data into train and test sets. We are using linear regression model from scikit-learn's linear model package. Metrics are for accuracy calculation. %matplotlib inline is a magic command that includes the plots in Jupyter Notebook next to the command. Now we see that all the libraries are loaded. So moving on to the second step, loading the data. So loading the data. As the input data, we are going to use Excel sheet cars.xl. This is one of the publicly available datasets that comes loaded with our library when we installed it. Here is the link we can download it from. http://courses. I have shared the link with you and that is available here, so you can download it from there. The dataset available at this location is fairly clean, but in real life, every now and then we run into bad data with junk characters like star, dollar, hash, question mark, so on and so forth. As we get missing data in the form of zeros, blanks, nulls, etc. Again, it's common to get data having incorrect format. Sometimes we can also get unwanted rows, etc. All these imperfections hamper our data processing. So for the purpose of demonstration, I have added such contents in my copy of the above dataset that we'll load now. The name is carseditdemo.xls. We will see how we can get rid of this defective data. I'm sharing this modified Excel sheet separately. However, you also can add the defects yourself and test how you can remove them as an exercise. We shall use Pandas method readExcel to read the input dataset from the local path where I have saved it. Now let's run the instruction. So we're going to load the library now. df_cars equal to pd.readExcel open parenthesis c:/users/ so this is the path where I have saved it. You can put your path instead. Cars underscore edit underscore demo dot xls close quotes, go one step forward, then comma, skip rows equal to open bracket 0. So let's press shift enter. So it has accepted the instruction. Now, as we know, this step has internally set up a data frame we named as dfcars for our internal processing. We have dropped the row with the URL by using pandas option skip rows, row number. Specifically, we have used skip rows equal to 0, which is the very first row with URL. With this now, we are ready to go over to the third step, pre-processing and exploring the data. Pre-processing and exploring the data. Most of the data handling operations require data that is clean and in correct format. Pandas provides many convenient methods that help us to visualize or correct the data anomalies. These steps are essential prerequisites that we must perform before data analysis or data modeling. Here are some of the methods that we shall study now. Pre-processing, checking and cleansing the data. .head method. Pandas provides .head and .tail methods to view the top and bottom few rows of the data frame. Using this, we can check the data format, number of decimals, etc. The default is 5 rows, but we can specify any other number if so preferred. For example, we can specify .head into parenthesis 10 or .tail into parenthesis 25 if we want to look at so many more rows. Now, how do we make use of this feature? We can visually check the contents of the top or bottom few rows and make sure that there is nothing unusual to the eye and data format etc. looks as expected. So let's now run the instruction. I'm going to type it now. df_cars. This is the name of our data frame. df_cars dot head. Shift enter. So this gives the top 5 rows. Now we try the next one. df underscore cars dot tell. Let's say we want to see 10 rows. Shift enter. Okay. So now pandas returns top bottom 10 rate because we are saying dot tell. So it returns the bottom 10 rows. We see that the column horsepower is showing all integer values but is defined as float. So we may consider changing the data type as integer. Now next we look at dot is null method. When the data contains a mix of irregularities like missing data, showing zero values or blanks or non-alphanumeric characters like star, dollar, etc. How do we handle that? Pandas provides us with dot is null method. Here is how we can use the method. So what do we want first here? First and foremost, we want to locate where exactly the bad characters are lying. Dot is null method allows us to get a column-wise summary of these anomalies. Normally it's sufficient to get a total count in a column. So dot sum method gives a total count in the column. So we combine these two into one instruction that will give us column-wise total counts. So let us try the below instruction. So I'm going to type the instruction now. You also try. df underscore cars dot is null. So we are asking pandas to pull out the null columns dot sum. So tell me how many bad instances are there. So shift enter. So now let's see what is showing. The response tells us that the column horsepower contains 3 cells where we have some unwanted characters. Now we have identified the columns of the problem. Now what next? Next we want to reach the exact rows where the bad data are lying. For this, we look up the rows where the content is other than a real number. So how does the code look like? So let's try that out. df underscore cars, this is our data frame's name, dot loc. Then into square bracket tilde not equal to df underscore cars dot horsepower dot apply. So apply is the standard pandas method to apply on individual cells into parenthesis np dot is real. So we are asking everything that is not is real to pull out. So it will pull out all the rows that are exactly showing. Shift enter. So now if we see, it is, so we have a summary of the row wise exact bad data. We find that it's a mix of many types. Our next task is to replace all these mixed types of bad characters by a uniform pandas standard NaN value. We can use below instruction to achieve the same. The first part of the instruction is same as before, followed by comma column name. So I'm going to copy it from here. We need not retype the whole thing. So I will copy this part, Control C, reproduce here, is real, comma, then I extend it from here. Single quotes, horse power equal to np.nan. Shift enter. Here we have converted all mixed types of junk characters into standard uniform NaN format. Note that 0 being a real number, it will escape the not real filter when we replace the rest of the types. So it must be replaced separately as follows. So this, just to make sure that we do not have any 0 values, we can just type this out here. Now we want to be sure that the entire bad content was in fact replaced by a null nan value. So here it is. We shall check the one of the bad rows to verify that. Now we know among the rows above that row number 13 has a bad character. So we will look for contents in number 13. So how do we do that? df underscore cart dot loc square bracket 13. Shift enter. So now if we check, so here it is shows that the bad content is already replaced by NN. So now if we check again by repeating the earlier instruction for not real numbers, you know this instruction already, we find that all the data is clean. How do we do that? Let's get back here. So it's the same instruction as above. We have typed it earlier. So I'm just going to copy it from there and bring it here. So what do we see here? We see that there is not a single row that contains a non-real number. It means that we have completely converted mixed junk characters into standard null format that Python understands. At this time, we can apply one of the many alternative strategies of imputing the data. That is, we can replace the uniform nan values by either the mean of entire column or the median or mode, or maybe we can drop bad rows altogether. So which one should we go for? The answer is there is no single right solution. We need to take a call from case to case. Let's replace nans with say mean value of the column and recheck the summary. So here is the instruction that will do the job for us. So let's type this one now. df underscore cars open bracket horsepower equal to df underscore cars square bracket horsepower dot fill NA. So we are asking Pandas to replace our earlier horsepower column wherever there was bad character by standard NA, and dot fill NA should replace by df underscore cars square horsepower dot so it has done the job for us. It has already accepted the instruction. Alternatively, we could have used the median of a column or as a substitute. A median is a value located at middle position in the data rather than the arithmetic mean. The instruction is identical to the above with dot mean replaced by dot median. There is also a third option of dropping a row if there are too many NNs. Let's say we have a row where more than 50% of the values are missing. So in that case, it makes no sense to reset so many values that are means or medians. In such case, it may be a preferred option to drop the rows with too many NNs altogether if such rows are few in numbers. I am providing these useful instructions under the notes for a handy reference, so you can use it wherever you want. So right now we are good. So we are next instruction df cors dot loc 13. Again our earlier instruction where we checked the content of row 13. df underscore cars dot loc (13). Shift enter. So what do we see here? In horsepower, in row 13, now we have replaced NaN also by the mean of the entire horsepower's column. Now we have cleaned the data, so we can move on to the next part of pre-processing, which is getting all the data in the right format, checking and correcting the data format. .dtypes and .stypes method. Pandas .dtypes method allows us to check the data type of a column. So let's run the instruction. What is the instruction? So simply df underscore cars dot d types, shift enter. Okay, so what do we see here? We find that the data contains horsepower as integers, but it is set up as float in the data frame. We need to take a call based on analysis of the content. Let us say we want horsepower to appear as integer or vice versa. Maybe we want the integers to be converted to float. Pandas provides a method .asTypes that lets us change the data type of a variable. So let's modify and then recheck the data types. So how do we do that? So let's do the next instruction now. df underscore cars square bracket horsepower equal to df underscore cars square bracket horsepower dot hash type round bracket or parenthesis int 64, and we change the format and then we check again df underscore cars dot d types. This is the same as our earlier instruction. Shift enter. So now we see, what do we see? We see that horsepower is converted to int like we wanted. So what all have we done so far? We have completely cleansed the data. We have corrected the data format. In short, we are done with the pre-processing and are ready to explore the data. That is to do data visualization. Now moving over to exploring the data. Some instruction for overall view of the dataset. .shape method. This is the instruction to check the size of the dataset. Let's run the instruction. df cars.shape df underscore cars dot shape shift enter. We see that our data frame df cars has 394 rows and 9 columns. Length data frame method. To know only number of rows. Earlier we saw rows and columns both, but let's say we want to know only the number of rows. Then we use length data frame. So how does the instruction go? Let's see this here. Len parenthesis df underscore cars shift enter. So it answers 394. There is one more important instruction .describe to get the statistical summary of all columns like count, minimum, maximum, quartiles, etc. We have .describe method. So let's type the instruction df cars .describe df underscore cars .describe open close parenthesis shift enter. Right. The response is showing us a quick statistical overview of each numerical column in the dataset. Remember that it talks only of numerical columns and not the categorical ones. Number 1, count tells us the number of rows. Mean tells us the arithmetic average, while the median tells the middle value. Median and quartile values tell us how the values are distributed. Min and max tell us the range of the values within the data. The information will be clearer when we see box plot of these fields. So that we'll see as we go forward. So now that we have an overall view of the data, we shall study the pattern in detail. This is done by various types of visualizations. First, we shall look at the numbers, that is numerical analysis, followed by the look and feel of the data. So let's see how we do that. Non-graphical univariate analysis. Univariate analysis is analysis of one feature at a time. Non-graphical means it contains only summaries in numbers, that is no charts. It helps us as a quick check in understanding the distribution pattern within a single column. It also allows us to divide the data into logical groups on the basis of some column, say as in our example, the number of cylinders. Now let's see .unique method. Method .unique returns a list of unique values. Let's see how we can use it. df underscore cars, open bracket, single quotes, origin, bracket close, dot, unique, open close parenthesis, shift, enter. The response shows a complete list of countries whose car models are included in the dataset. Now, value counts method. Method value count gives us complete details of each unique value within a column with its respective count. So let's run the instruction and study the response. So how does it go? df underscore cars, open bracket, let's say cylinders, single quotes, cylinders, get across the bracket, value underscore counts, open close parenthesis, shift, enter. The response tells us that maximum models present in the data have 4 cylinders 201, followed by 8 cylinders 103 and 6 cylinders 83. 3 and 5 cylinders models are insignificant and can be ignored from analysis. Using this information, we can filter and subdivide data into logical groups of interest. Let us see how we can do this. Let us say we want to study the behavior of one or two specific items that are most frequent to represent the data. For example, we can select all cars with 4 cylinders, or maybe all models that were created in USA. Below instruction uses a filter to segregate all 4-cylinder car models in the data. So let's run it and view the response. So let's type the instruction now. df underscore 4cell. So this is the name of a new data frame we are creating because we don't want to disturb df card. df underscore 4cyl equal to df underscore cars, open bracket, parenthesis, df underscore cars, open bracket, single quotes, cylinders equal to 4. So we are asking Pandas to pick only all those car models who have 4 cylinders and not 6 or 8 of this earlier df cars data frame and segregate them, put them together in a data frame and name that as df underscore 4cell. Now, just to check what we're going to create, we also do a follow-up instruction df underscore 4cyl dot describe, open close parenthesis, shift, enter. So see that we have created a separate data frame by the name df underscore 4cell that has got number of cylinders only as 4 and all the rows are segregated like we wanted to do. So we have done this part now. As you can see, 4-cylinder car models across all countries from a homogeneous group as it was created with a common intent of high fuel efficiency. Summing up, we have separated 4-cylinder car data and created a separate data frame by the name df4cell. We shall use this in the part 2 of this project execution as we'll see later. Now, graphical univariate analysis. So far what we are looking at was non-graphical analysis. That was only numeric summaries. After non-graphical analysis, let us now study the visual side of univariate analysis called graphical analysis. This gives us a more detailed information and it's easier to visualize. So first one comes is the histograms. Histogram is the most commonly used graph to represent numeric data. Histogram provides a graph of some feature like say MPG shown below plotted against is frequency of occurrence in the data. In histogram, we divide the total range of MPG column values into number of bins of equal size and study the frequency in each bin. So let us run the below entry to generate a histogram for MPG, that is miles per gallon, as it is our target value of this project, right? So using Matplotlib library. So how do we do this? Let's try this instruction. df underscore cars, open bracket, MPG, get across, go next position, dot hist. Hist is histogram, round bracket, bins equal to 12. So this number can be anything. So we are telling Pandas that you divide the entire data into 12 such bins and create a histogram of MPG values of df cars. So shift enter. So see that it has generated a histogram here for us. The second type of histogram shown below is an alternative to the one above. It is generated using Seaborn package and it's a bit more sophisticated and gives more statistical detail. So this is only standard syntax, so we will not waste a lot of time in typing each instruction. I will simply copy it from here and run it. So let's do it here. So plot.figure, fixed size. We are telling 8,5. This is the figure size. Type layout. This is the type of layout we are looking at. This is the standard syntax. sns.dispplot df cars mpg. So we are asking it to create such a histogram using Seaborn package. Shift enter. So look at this. Alongside the histogram, it is also given a curve which clearly shows how the statistical distribution looks like. We can derive following information from histograms. How the data is distributed. For example, whether it is normally distributed or skewed. Normally distributed data speeds up the machine learning process and can get better accuracy. We can also get an indication of outliers, that is values isolated from majority trend. The above diagrams show this data is skewed to the right hand. We see the long tail that is appearing, that we indicate as the skewed right. So this you will see maximum number of columns on the right hand side. So it is the right skewed. This skewed distribution could be due to mix of 6 and 8 cylinder engines, which show a distinctly different behavior than the majority 4-cylinder engines. That is, the higher frequencies are more concentrated towards the lower displacement. This is because lower displacement indicates 4-cylinder engines. In other words, data shows that 4-cylinder engines are more common than the other types. In case of skewed data, as we will see, sometimes can group data differently for better uniformity. So the next one coming up is the box plots. So what are box plots? A box plot is the visual representation of statistical summary of given data set. The summary includes minimum value, the first quartile, that is the point below which 25% of data lies, median, that is the second quartile, 50% of data lies below the median, third quartile, 75% data below the third quartile, maximum, then the outliers in the data set. So let us run the below entry to generate a box plot of horsepower. So let's type the instruction. df underscore cars dot box plot, round brackets, column equal to horsepower. Shift enter. So what does it tell us? The above graph clearly shows the collection of points above the maximum value, which are the outliers. So in this figure, you can clearly see that all these points here on top, this is the maximum, this is the upper quartile, this is the median, this is the lower quartile, and this is the minimum value. So all these points are outliers. Below entry generates a more classified information of horsepower distribution grouped by cylinders. We can also break this down by the different types of cylinders. So that will give us the clearer distribution how each of the group by cylinders is distributed. So let us run the entry to generate it. So how do we do that? df underscore cars dot boxplot parenthesis column equal to horsepower. Close single quote by equal to single quotes cylinders cy cylinders. So let's try this out. Shift enter. Okay. So this has generated us like we wanted the classified by cylinders. The multiple history below is another alternative box plot representation by Seaborn.